Welcome to part one of the Preparing for the ACT 2021-2022 prep packet. If you're looking for a particular solution to a particular problem, go take a look in the description. I'll have put timestamps for all the problems here in this particular video. So let's start with number one. So we're told that numbers 1 through 15 were each written on an individual piece of paper, and then one piece was drawn out of the jar at random. Now the question is, what's the probability of drawing a piece of paper with a number less than 9 written on it? Now a lot of people are quick to think that the answer is letter B, but actually it's not letter B. And they think that because, well, it says one piece of paper. But the thing is, what we have to take into account is the fact that, well, we want numbers less than 9. So let's think about this. We got 1, 2, 3, 4, 5, 6, 7, and 8 out of a total of, well, let's see, 1 through 15. So the question is, how many ways could we get a successful outcome? Well, there are 8 different ways, because each of these numbers count individually out of a total of 15. And so that's why your answer is actually letter E. All right. So moving on to number 2. Here we have negative 4x cubed minus 12x squared plus 9x. So we're combining these 3 terms. The question is, which 2 are like terms? Now the thing that tells us which ones are like terms are the variable at the end. So we have x cubed, and x squared. So that means that these 2 right here are the like terms. So when we're adding or when we're subtracting, we have to have the same type of term in order to combine them. So what that means is that 9x squared is not a like term. So 9x squared is going to be left out in the cold. Now, we already know that J is the right answer, but because we know that 9x is not going to be combined, we know that we can eliminate letter F and letter G. There has to be a 9x squared in our answer separately. So what that leaves us with is negative 4x cubed minus 12x cubed. Now really all we care about are the number part. So if we can just drop the x cubed and say, all right, we'll take negative 4 minus 12, that's going to be negative 16. And so that allows us to get rid of letter H. Now the temptation is, well, combine the x cubes. No, the x cubes are just there to tell us what type of number they are. And so think of it as we owe $4 and now we owe 12 more. So that means this is still the same type. It's still negative 16x cubed. So the answer is letter J. Number 3, here we have when x equals 2, we want to find the value of this expression. So what this is really just an order of operations question. So I'm just going to rewrite it, but instead of putting in x, I'm going to put in, first it's 3 times 2, like that. And so order of operations says you do parentheses first. Now when you have multiple parentheses, you always do the inside parentheses first. So that means this is going to happen first. Now every step I'm going to rewrite everything else that doesn't change. So this is all the same, then 3 times 2 is 6. So now one set of parentheses is gone. We still have one other set of parentheses. So that means next we're going to do 12 divided by 6. So 12 divided by 6 is 2. Now technically we have a parentheses, but not much is really happening here because there's nothing really to do. It's just 2. So now we have 10 plus 3 times 2. So that means this is happening next. So 10 plus 6, and that leaves us with 16. All right, number 4. Now with this one, absolute value is kind of like a parentheses. The only difference is that at the end, what you do is that whatever's on number is on the inside, you make it positive. So the thing is, you first have to compute what are these two numbers here. 6 minus 4 is 2. And then 3 minus 8 is negative 5. You only take the absolute value when there's a single number inside. So that means, well, absolute value of 2 is 2, and absolute value of 5, negative 5 is 5, and then when we subtract, we get negative 3. So moving on to number 5. Here we want to multiply these two quantities. Now to do that, each has two terms. So what I'm going to do is first I'm going to multiply the 4c onto these two terms. So let's see, we got 12, and then c times c is c squared. 4c times d is 4cd. And then I'll multiply these two. Now don't forget that there's a negative here. And when we do that, we're going to have to multiply the whole quantity of negative 3d onto that. Got to remember that. So now I'm going to take negative 3d times 3c, so that's negative 9cd, and then minus 3d squared. Okay. Now these two middle terms are going to combine. But what we can do is we say, all right, well, this has to have a c squared. This is not going to combine. So all our answers have a c, 12c squared. Can't eliminate anything with that. But our answer also has to have a minus 3d. So that means we can eliminate letter B and letter D because those have positive 3d squared, which is not what we want. So similar to number 2, when we combined those, we say, all right, well, we've got 4cd minus 9cd. So we just look at the numbers, the coefficients out front. 4 minus 9 is negative 5cd. So out of the ones that are left, the only one that has a negative 5cd is letter C. Number 6. Of the 180 students in a course, 1/4 earned an A, 1/3 earned a B, and the rest earned a C. How many earned a C in this course? All right. Two ways you can go about this problem. One way is to say, all right, how many students earned an A? We know that 1/4 of the students earned an A, but what's the number? So we take 180 times 1/4, and we get 45 students. Then we ask, all right, how many students got a B? 1/3 of the students earned a B. So we take 180 times 1/3, and we get 60 students with a B. So the question is, the rest got a C. So the question is students with C. But what we do know is that all of this has to add up to 180. So if we take 45 plus 60 plus x, and we get set it equal to 180. Now, what some people will do is some people will combine these two and then subtract from 180, and what other people will do is they will subtract each number individually. Either way, you get x equals 75. All right. What some other students may try to do is, what they'll say is, okay, 1/4 of the class earned an A, 1/3 of the class earned a B, so what's the fraction of the class that earned a C? So what we have is let's draw a line, let's do it separately. So we have the whole class, so we'll say that's a 1, minus 1/4 minus 1/3. Now, whenever we add or subtract fractions, we have to have a common denominator. So we've got 4 and 3. So the lowest number that those both have in common is a 12. So that's 12 over 12 minus 3 over 12 minus 4 over 12. And when we make that subtraction, we have 5 over 12. So that's the fraction of the class that got a C. So then we multiply that by 180, and we're going to get 75 for this problem. Number 7. They give us a formula, this function right here, and it says x represents the number of years after the beginning of the year 2000. Now, what was nice about this problem is they gave you an example. X equals 0 represents the beginning of the year 2000. Underline that. And they also give you another example. X equals 1 represents the beginning of the year 2001. Now, we're asking how many fish were at the beginning of the year 2006. So following this pattern, x is going to equal 6. So we're going to take this formula and we're going to put 6 in there. So following order of operations, we're going to take 2, raise it to the 6th power, and we get 64. And then 3 times 64 is 192. So let's move on to the next page. So number 8. Manish drove from Chicago to Baton Rouge. At 8 a.m., he was 510 kilometers away. At 1 p.m., he was 105 kilometers from Baton Rouge. So which of the following is closest to his average speed in kilometers per hour? So we got Chicago over here and Baton Rouge over here. Now at some point, we don't know where, call that 8 a.m. And then at 1 p.m., he was closer. So the question is, in this time, right here, what was his speed? Now we do know that at 8 a.m., he was 510 miles away, or kilometers away. And then at 1 p.m., it's 105 kilometers. So if I subtract these two, 510 minus 105, that gives me how many kilometers are in between these two, which is 405. And also, I can say, all right, well, from this time to this time, from 8 a.m. to 1 p.m. is how many hours? Well, it's 5 hours. So now I've got the change in distance, and I've got the change in the time. And that allows me to find the speed. Because that's what speed is. Change in distance over the change in time, which we just calculated. 405 kilometers over 5 hours. And that gives us 81 kilometers per hour. So moving on to number 9. So here we have this shape, and it tells us that these 3 lines are parallel. Now the reason that that's important is it means these angles here are all congruent, and that these angles here are all congruent. Now, why does that matter? Well, there's 2 ways to go about this problem. I'll show you both of them. One way that I'll often show students is to look at this and ask, all right, what are we asked to find? We're asked to find the length of AC. That is this whole length right down there. That's what we want to figure out. Now that is part of this really big triangle right here. Oops. From here all the way to here. That's the big triangle, triangle ABC. And over here I'm just going to label it. So triangle A, B, C, right there. Now we know one of those sides. We know 21. And what we're asked to find is this side right here. The problem is, well, we need more. Well, we do know this triangle right here. Now, these two triangles, triangle ABC that I just drew in blue, and ADC that I'm drawing right now in red, are similar. How do we know that? Well, I just drew the fact that this angle and this angle are the same, and this angle and this angle are the same. And so when you have, and if you want to be technical, angle A is always the same. So when you have two triangles that have the same angles, what you have is you have two triangles that are just, one is a blown up version of the other. So the question is, if that's true, then what do I have to multiply by to go from 8 to 21 and then do the same thing to get 16? Well, everything is just proportional when you have similar triangles. So I can do 21 over 8 equals x over 16. And so when I cross multiply, I get 8x equal to 21 times 16, and we get 336. And then when we divide by 8, we get 42. Now that's one way to look at this problem. The other way to think about it is like this. So if you like this way, the first way of doing it, just do it this way. Or you can think about it this way as well. Anytime you have lines that are parallel like this, then this relationship that you see from here to here, it's going to be a similar relationship here and a similar relationship here. So what happens? Well, from 8 to 16, it's times 2. Well, same thing is going to be true here, and the same thing is going to be true here. It's just doubled. So this side length is going to be 14, and this side length is going to be 12. So 16 plus 14 plus 12, when I add those three up, that is going to equal 42. So that's the other way to think about this problem. Number 10, Katerina runs 15 miles in 2.5 hours. What is the average number of minutes it takes her to run 1 mile? All right. So a lot of people, when they think about this, they think, okay, well, I've got miles and I've got hours. So I take 15 divided by 2.5. And when we do that, I get 6. And we think that's the answer, but it's actually 10. Now, why is that? Well, that's because we're not asked to find the number of miles she runs in an hour. Rather, we're asked how many minutes does it take for her to run 1 mile. So what we have to do is we have to ask kind of a different question. 15 miles takes 2.5 hours. So 1 mile takes, now we're assuming she runs the same average miles per hour the whole time. So it takes her 2.5 hours to run 15 miles, so what's one of those miles? Well, we'll just take 2.5 divided by 15. And when we do that, we get 0.16 repeating hours. Now that is actually a fraction. That is actually 1/6 of an hour. But the problem says what we want is we want this in the number of minutes. So since we want the number of minutes, what we have to say is, well, multiply that by 60 minutes, and what we get is we get 10 minutes. And so that there is one way to approach this problem. Next one, number 11. Now this problem has actually shown up several times on several ACT tests. They actually recycle some problems. So it says a bag contains 8 red marbles, 9 yellow, 7 green. How many additional red marbles must be added to the 24 already in the bag so that the probability is 3/5? So to start off with, it's fair to ask, all right, what if we don't add any? What's the probability? Well, we've got 8 red out of 24 total. Well, that's going to be a probability of 1/3. Now, the more reds we add, the more likely we are to draw one, which means the probability will go up. So the question is, how many of these do we draw? Now, this problem is an excellent example where just picking an answer and trying it is a good course of action. Now, the one mistake that students always make is they always start by guessing letter A. And the reason that's wrong is because, well, if you're wrong, the only way to go is up. The better choice is to start by guessing in the middle. Because if you're wrong, not only do you eliminate letter C, but if you can guess which direction you need to go, you've eliminated 2 more answers. So by guessing 1, you can actually eliminate more than half of the possible answers. So we'll do that. What if we add 20 red marbles? Well, we have 8 already. Now we added 20 more, so it's going to be 8 plus 20. However, because we added more marbles to the bag, that's also going to add to the total. So we have 28 over 44. Let's see. Can we take out, well, we can take out a 7. Or sorry, take out a 4. We're left with 7 over 11. And that does not reduce, unfortunately. Now the question is that bigger or smaller than 3/5? So a decimal approximation is 0.636363, so on, dot, dot, dot. Now what's 3/5? Well, 3/5 is 0.6. So this tells us that letter C is too big. So we can cross off letter C, letter D, and letter E. Now the ACT is big on wasting your time. And so they will give you problems like this knowing that you'll try all of them. So when you guess, always guess the middle one first and use that against them. That way you can say, oh, this one doesn't work, so I eliminate all these other ones. Okay, well, it's 0.63, but it's close. So let's try 16 then. So we have 8 plus 16 all over 24 plus 16. And when we do that, we get 24 over 40. And let's see, we can take out an 8 from both of those. And there we go. We've got 3/5 as our probability. So that's why we have to add 16 more marbles in order to get that probability up from 1/3 all the way up to 3/5. Number 12. In the standard XY coordinate plane, so anytime you see that, anytime you see this phrase right here, a lot of people get weirded out by that. All that really means is this. You've got X and you've got Y. That's all it means. The point 2, 1 is the midpoint of CD. Point C has coordinates 6, 8. What are the coordinates of point D? Now, some students will want to draw that, and for those of you who are very visually minded, you can do that. But I think that may actually be a bit of a waste of your time. How do I mean? Well, let's see. We've got point C over here, and then we've got point D over here. Now the midpoint, call it M, is right in the middle. Now that has coordinates of 2, 1. And they say that point C has coordinates of 6, 8. And so the question is, what are the coordinates of point D? Now what you need to be thinking about is the fact that the x's and the y coordinates are kind of distinct from each other. So I want you to think of them like this. In that, okay, the y coordinate of 1 is halfway between 8 and another number. And the same thing goes for the x coordinate. 2 is halfway between 6 and a number. Now, if counting that is too difficult, well, this is where the midpoint formula often comes into play. And some students will say, well, I'll just memorize the midpoint formula. Yeah, you can do that. That's fine. But this problem is kind of designed to attack that because some students think that the midpoint formula is only good for finding the midpoint. Well, here they gave you the midpoint. So it's a little bit trickier than that. But here it is. The midpoint formula says that if you want the midpoint, you just take the two x's, x1 and x2, and average them. And same thing for the y coordinates of the ends. y1 and y2, add them together and average them. Well, here doesn't quite work as well. Because here you've got 6 plus x2 over 2 equals 2 for the x. And then for the y, same thing. 8 plus y2 over 2 equals 1. Now, can you solve it? Absolutely, you can solve it. No problem at all. Multiply the 2 out and subtract the 8. You get negative 6 over here. Over here, you get 6 plus x2 equals 4. X equals negative 2. So that's why the answer is letter G. Now, you only actually had to do one of these, because you could have actually eliminated them down most of the way. Now, it's better to do both of them to be absolutely sure, both the x and the y coordinate. All right. Number 13. At his job, the first 40 hours of each week that Thomas works is regular time, and any additional time is overtime. Thomas gets paid $15 an hour during regular time. Let me underline that. Regular time. And then during overtime, he gets paid 1.5 times as much. Now, they don't tell you how much he gets paid, and that's kind of a trick that they do. So it's almost good to stop and say, wait a minute, if he gets paid $15 an hour during regular, and he gets 1.5 times as much during overtime, how much is that? Well, that's 1.5 times 15. Let's just do that real quick. 22.5. So he's going to get paid $22.50 an hour. So Thomas works 40 hours in a week and gets $117 in deductions taken out of his pay. After the deductions are taken out, how much of his pay remains? All right. So, whoops. So he worked 46 hours. So we got 40 hours of regular time and 6 hours overtime. So over here, this is going to be 40 times 15. And down here, this is going to be 6 times 22.5. So he's made 600 for regular time. And then for overtime, made 135. So altogether, that means he made $735 before tax. But that's not the answer. Why is the answer letter D? Because of this extra detail. He gets 117 in deductions taken out of his pay for this week. So we have to subtract $117. And so we get $618. That's what he gets to take home. Number 14. So we have this produce store. They have a price of a bag of grapes. It depends on the number of bags purchased. So if you buy 1 to 3 bags, it's $3 a bag. 4 to 6, it's $2.80. 7 to 9, it's $2.60. And $10 or more, it's $2.50. So in 2 trips, Janelle purchased 3 bags on Monday and 4 bags on Wednesday. How much would Janelle have saved if she instead purchased 7 bags of grapes in 1 trip? So on our first trip, she purchased 3 bags. So 3 bags times $3 a bag equals $9. Then she had 4 bags times $2.80 per bag and that gives us $11.20. So how much did she pay in total? She paid $20.20. Now, we compare that with 7 bags times $2.60 a bag. And when we do that, we get $18.20. So, $20.20 is how much she paid. $18.20 is how much she could have paid. So the question is asking, what is the potential savings difference? So when we subtract that, we get $2. That's why our answer is letter J. Number 15. What is 3% of 4.14 times 10 to the 4th power? Now remember, whenever you have a percent, you have to move the decimal point 2 places over. So 0.03 is what 3% is. So what we're doing is we're multiplying 0.03 times 4.14 times 10 to the 4th. Now really what's going on here is we've got decimals being moved left and right. Because what this is telling us to do is move the decimal 4 places to the right. So we've got 0.03 times, so 4, and then we move it 4 places, 1400. Now here we've got this 0.03, and that's telling us we'll just move it 2 places to the left. So by doing that, we get 3 times, and I'm just going to move the decimal point again, 414. And we get 1,242. Now some people ask the question, why don't we just type that computation in to begin with since we're using our calculator? And you'd be right. You'd be absolutely right. But the thing to remember is that the ACT is designed so that if you don't have a calculator, you can still do it. Now, for some of you, that's a crazy idea, but it's true. You can take the ACT if you discipline yourself to actually not be dependent on the calculator. But if you have it, might as well use it and save yourself some time. All right, that's all for part 1. Thanks for watching, and I'll see you in the next video.